Yeah, hello class. These are the examples, homework problems, solve homework problems in section 6.2 and 6.3. All right. Now these problems are in the PowerPoint. So, but I wanted to do the video so that it will save some class time. All right. Now here is question number 8 on your homework. Similar to this, the percentage will be different, but this is how we're going to show you how to solve it. It says engineers want to design seats in commercial aircraft so that they are wide enough to fit 90% of all males. Accommodating 100% of males will require very wide seats that will be much too expensive. Men have hip breadths that are normally distributed with a mean of 14.6 inches and a standard deviation of 1.4 inches. Find the upper P subscript 90, which is the 90th percentile. So this means that find the hip breadth for men that separates the smallest 90% from the largest what 10%. Okay, so in this case, to solve this equation, right, some things we need to know. All right, so let's go to the note this is the standard deviation, and that is your mean is what 14.6 inches. All right, and then we want what the 90th percentile. Okay, now to solve this, let's write down what is our x variable. So the random variable, I call it NV. X in this case is what the hip what breadth, okay, of what of men. According to the question, that's what the variable is. Okay. Now we know that the mu is 14.6 inches. The standard deviation is 1.4 inches. Okay, 1.4 inches. All right. Now, what we need to know is I said that we ought to find a P subscript 90, which is in this case is the 90th what percentile. It's the 90th percentile. Okay, the 90th percentile. Okay, so as always, first we don't know the x, okay, but we want to find the z-score that corresponds to 90% to the left and then 10% to the top. All right, so it's like we want the probability. In this case, they want the probability that your x is less or equal to a certain value, okay, which is a hip breadth that we are going to look for, is equal to what 0.990. Or we can also look at it this way: the probability that your x is greater than or equal to a certain value, let's call it this b, is equal to what 0.1. But I want to just concentrate, use this case. Okay, now in this case, you know that we have to find our z-score. Okay, the z-score, which will be this in terms of z. Okay, in terms of z, this will be the same of a certain value, a. Okay, it is equal to 0.9. Now, if I draw the density curve, if you draw the density curve, this is how it's going to be in terms of z. So you need to first determine your z-score. Okay, so what is the z? What's the z-score for this? Okay, now we know that the mean is what 14.6. That is the center. Sorry, that's the center. And then we want to find the x. Okay, x such that we don't know the x, such that this part is all what 90%. Okay, now this is the same as in terms of the z. Okay, in terms of z, remember the z has a mean of what 0 and standard deviation of what 1. So this is 0, and so we want to find the z-score, okay, which is 0.9, okay, such that this part is what 0.90, or the top is what just 10%, which is 0.10. Okay, now you can use the table or the StatCrunch. So let me use both of them to show you, because this one is tricky. We're going to pick one that is very closest to it. Okay, and so let's go to the table. Let's bring up the table. Now, the table we are looking for what? The probability is, this is an inverse. The probability is what? 90%. We want to find the z-score that corresponds to that. Now, as you can see, okay, the closest value, or if I look at this table, it is this value here. Okay, is it this value, which is what? 0.8997. It is closer to 90% than 0.98980 or 901, because it's only the difference in this case is 0.003. So here you pick the closest. And what is that z-score? It is 1.2, okay, 1.2 under what? Under 8. Okay, 1.2 under 8, which is what? Which is this value right here. Okay, so that is our z-score. Now, if I want to use the StatCrunch, okay, I'll have this. This is, you go to your, okay, the StatCrunch, as you can see now. All right, how do I get here? First, you go to statistics and calculators, and you pick it. This is a normal distribution. Okay, so that's what I got here. Now, z-score is what do you call it? The m, mean is what? 0, and then standard deviation is 1. Okay, now we want our probability is what? 0.9. We want a z-score that's less than that. Okay, now look at it. To 2 decimal places, that is 1.28. Okay, just like we use a table we got from the table. Or if I change this to greater than or equal to, then I need to do this one. This is 0.1, and that should give me the same value. See that? So that's why I said that you can consider only the 10% to the top or 10% to the what? To the left. Okay. All right. So if you have that, okay, if you have this, then we can go back to our PowerPoint. Okay. Now notice that I need to make something here. This is a critical value. So it is not, critical value is what? The z subscript 0.1. Okay, not 0.90. Is 0.1. Then this is what we just found is for 1.28. All right. So if there's 1.28, then what is the x value? That will give me this. Okay. So that's when we use the formula. X is equal to the mu. So the mu plus what? The z-score that we got times what? Times the standard deviation given the question. So this is what? 14.6 plus 1.28, okay, times 1.4. Now, if you evaluate this, you get what? 16, you get 16.4 inches. 16.4 inches. So it means that the hip breadth for men, this is inscribed for the seats, all right? The hip breadth for men, the seats should be of what? Of this is the how wide that should be. 16.4 inches, so that it will accommodate 90% of males. Okay, so this says that the hip, okay, the hip breadth of men is 16.4 inches. Okay, this is the hip breadth of all the seats, the aircraft seats. Okay, of men should be what? 16.4 inches. All right, and then of course, this is how to accommodate this to accommodate how many? Accommodate what? 90% of what? Of men. That should be there. Okay. Now look at this 16. I can use the StatCrunch without calculating the z-score first, and then find the what? That percentage. Okay. Let me show that to you. Okay. So go back to our StatCrunch. Okay. Go back to the StatCrunch. So you go to calculators and then normal distribution. Okay. Okay. Now the mean according to the question is what? 14.6. 14.6. The standard deviation is 1.4. Okay, now I want the probability 0.90, sorry, that is 0.90 to the left. So what is the X value? Okay, that would give me this probability. If you compute this, now look at this. Okay, if you use this, you have a 16.39 to one decimal place, it will be what, 16.4 inches. All right, so if you are using the table, that's when you have to calculate the z-score first, and then you use that formula that I gave you, that's X is equal to the mu plus the z-score times or sigma, and you give her the same thing. But if I'm using the software, I don't need to use the standard normal, since I know the mean and then the standard deviation of the normal distribution, because it says that the head breadth of men is normally distributed with mean 14.6 inches and then standard deviation 1.4. Okay, so you can do it this way and get the answer without you going through other process. All right, okay, now let's go to the second example, okay, of 6.2. Now it says that for the purposes of constructing modified box plots, okay, outliers are defined as data values that are above Q3, that is the third quarter, by an amount greater than 1.5 times interquarter range, or below Q1, which is first quarter, by amount greater than 1.4, okay, 1.5 times interquarter range. So either below that formula, remember we use this in this class. So using this definition of outliers, find the probability that when a value is randomly selected from a normal distribution, it is an outlier. Okay, it is an outlier. So in solving this solution to this, first, what's our random variable? Random variable X. In this case, what does it represent? This represents what the outliers. Okay, here there's going to be a process. We're going to have quite a process here, because first we need to determine, okay, Q3 and then Q1, find our interquarter range. Then before we can use this formula to find the values, okay, the lower limit and the lower and upper limits. Then when we have finished, then we have to find the probability to the left and the probability to the right and add them together. And you notice that the probability to the left of this value and that value are the same. So basically you're going to multiply 1 by 2 to get your answer. Okay, because find the probability when a value is random selected from this, it is an outlier. It is less than the lower quarter, okay, all right, less than the lower quarter, which is that value, lower quarter minus 1.5 times interquarter range, or the upper quarter Q3 plus 1.5 times interquarter range. All right, so this is what is happening. First, as always, draw your density curve. Okay, I draw my density curve. Okay, now this is what I want. I want to find, okay, Q3, all right, plus 1.5 times IQR. And then I also want to find Q1, Q1 minus 1.5 times IQR. All right, so we want to find this. So I want to find this probability. These probabilities, that's what I know. What is this probability? So this is what we want. Okay, that's what we want. But first, we don't know Q1, neither do we know Q3. All right, now these are, remember, you have 25% to the left and then 25% to the right. So the question is that what is Q1 and what is Q3? All right, now this is density curve will help me to see that. Okay, this probability is what, 0.25, the upper, and then below that is also 0.25. So this is where my Q1, and that's where my Q3. Now basically this is it is going to be the same value, but only that one is to the one is positive, the other is what, negative. So this is basically saying that you're finding the critical value Z, which is what, 0.025. Okay, now if I use a table, if I use the StatCrunch or the table, this is what I get. You want to find the probability that your Z, okay, is less than equal to, or say, Q1, which is equal to 0.25. Or you can say that the probability, the Z, is greater than equal to, oh, sorry, can also be less than equal to the Q3, and this is what, 0.75. Okay, so when you calculate this probability, this Q1 is equal to negative from the table. So you go to 0.75, just like I showed you in the previous example, 0.75 from the table, or use the StatCrunch to give you that. Let me show you how to the StatCrunch to find this. So go back to the StatCrunch, and we want what, 0.75. The standard deviation is 1. The mean is 0. So we want to find this probability. Okay, now look at it. What is that Z-score? Two decimal places is what, 0.67. And so Q3 is 0.67. Q1 is negative 0.63. All right. So then we go back to the PowerPoint. And that's why I got this value from 0.67. And then my Q3 is a positive of that. That's 0.67. So therefore, what is interquartile range? We know it is what, Q3 minus what, Q1. Now basically we have what, 0.67 minus 0.67. Okay, which will give us that's 2 times that, which is 1.34. Okay, so once we have this, then we need to determine the lower limit, okay, of the outlier. Okay, the lower limit of the outlier, which is what, Q1 minus 1.5 times interquartile range. Now, what is this equal? This Q1 is what, negative 0.67, then minus 1.5 times the quartile range, which is 1.34. Okay, so if we evaluate this, you get negative what? Negative 2.68. Then the upper limit, is what? Q3 plus 1.5 times interquartile range. And if we evaluate this, you get 0.67 plus 1.5 times 1.34. And that will give you positive 2.68. Okay, so negative 2.68 and then positive 2.68. So then we want to find that probability. Okay, find the probability that when X is selected, it is what? Random variable. It is an outlier. Okay, so then we want to find the probability. Okay, we want to find the probability that my Z, okay, which in this case let me draw. So what we have right now is this. Okay, so density curve. This is minus 2.68. And that side is what? Positive 2.68. We want to find this probability. Okay, we want to find the probability. So which is what? The probability that what the Z okay, it's less than or equal to 2.68. Okay, you want to find the sorry, this is minus, okay, and then we're going to add this to the probability that your z is greater than or equal to positive 2.68. Okay, now if I go to the start crunch, it will give me that value easily. So let's go back to the start crunch. All right, now I want to find this probability, okay, that is negative, okay, 2.68. Now let's calculate that probability, which is what? Which is this value here. That is 0.00137 to 4 decimal places. The table will give me the same thing, okay? The table will give us the same thing. If we go to the table, you have this. That is, by the way, this is a half of it. So the other one will be another half. So you add them together. All right. So if I show you the table, then we have for 2.6, 2.6 under what? Under 8. 2.6 is here. Under 8 is what? You're finding area to the left of what? That. So if you find the upper, okay, or you can use the negative, okay. If you find the negative of that, this is this value. And then when you subtract this from 1, you get what? The 0.00137. Okay. So start crunch will give us that anyway. And that's what I just showed you. Cool. So therefore, this what is happening is that this probability, each of this probability is what? 0.00337. This probability here is 0.0037. Okay, so the probability that, go back to the question, it is an outlier. It is what? Below this value here, and is what? Above what? That value. And then we just calculated that. So the probability that, okay, X is what? An outlier is 0.0037. And since they are the same, you just multiply them by what? By 2 plus was 0.0037, which is the same as saying that it was 2 times 0.0037. The 4 decimal place, which is equal to 0.0074. So this is what? This will be your answer for that. So in this case, if the probability that in the random variable, which is normally distributed, will have is an outlier, it is what? 0.74%. 0.74%. Okay. So now this takes us to the next section, which is section 6.3. 6.3 talks about estimators and saying that it's something is what is a biased or unbiased estimator. Okay, if it is an unbiased, it means that when we use a sample to calculate the population parameter, it will equal that. Okay, so in the PowerPoint, we'll do examples for proportion and then proportion and the median, and also a range, depends on the questions that we have there. But here we want to look at proportions. So the question is that if I have a sample proportion, okay, which is usually denoted by what? P hat. Okay, P hat. Is it biased or non-biased estimator? So here's an experiment that we want to look at. It says that a genetics experiment involves a population of fruit flies consisting of 3 males named Billy, Carlos, and what? Danny, and one female named what? Elena. Assume that 2 fruit flies are randomly selected with what? Replacement. Randomly selected with replacement. So if it is replacement, all right, you can select 2 of the males or the same male at the same time. If you have 2, you are selecting 2 of them. Okay. After listing the possible samples and finding the proportion of males in each sample, use a table to describe the sample distribution of the proportions of what? In fact, this is males, not females. Okay, proportion of what? Males. Okay, proportion of males. Now, to do this, all right, we want to make sure we are using letters. So use B for Billy, B for Billy, and use C for Carlos. And then for D, use it for Denny. Denny. Okay, and then we use Elena, E for Elena. Okay. So the question is, what are our possible samples? Okay, the possible samples in this case, okay, we can have, since we are selecting 2 at a time, we can have Billy and Billy. We can have Billy and Carlos. We can have Billy and Danny. And we can have Billy and what? Elena. Then we can repeat. We can select Carlos and then Billy, Carlos and Carlos, Carlos and Danny, and Carlos and what? Elena. Then we can also have Danny and what? Billy. You can have Danny and Carlos, and Danny, and Danny and what? Elena. And we have Elena, Billy, Elena, Carlos, Elena, what do you call it? Danny, and Elena what? Elena. Now remember here our X is what? Is find the proportion of what? Males. Okay, so we are counting how many males in these 2 samples. Okay, so possible samples are these. There are 16 of them. All right, now here you have what's a possible sample. How many males are there? You have what? The proportion. So we're going to say that X is the proportion. Now X in this case, okay, we're going to have X, and then here we're going to have X, which is the sample. What? This is the sample proportion of what? As a proportion of what males. This is a sample. Okay, sample proportion. Let me erase that and have it correctly written out for you. Okay, so this is the sample proportion of what? Males. Okay, so Billy is what? We have 2. Okay, that is 2 out of 2. And here you have what? Also 2 out of 2, which is equal to 1 anyway. Okay, how many males are there? This is 2 out of 2, that is 1. And then here's 1 male, so that is 1 out of what? That's the proportion, 1 out of 2. Now you have what? Here you're going to have 1, that's the 2 males. Carlos, that's 2 males, so that is 1 out of 12, out of 2. And then you also have 1 out of 2, and you have this is Elena. Okay, that is here is what? 1 out of 2. Now Danny and Billy is 2 out of 2, which is 1. Okay, so this is 1. X is 1 there. Over here, X is also 1, and here S is 1. And then you have what? X is what? 1/2. Okay, X is basically what? This the 1 is what? 2 out of 2. Okay, so take note of that. And then you have what? Here is 1/2. You get 1/2, 1/2, and here you have what? 0, because there is no male. They are both what? Females. Okay, so what is the sample population, sample what? Sampling distribution. So here your sampling distribution. Sample distribution, you have what? Sample proportion. Okay, proportion, okay, which is your X, all right? And then it's a probability. It comes with the X values and then the probability. So this is the probability. Okay, now if you look at the X values, the values are either 1, 0, or half. Okay, so we're going to write this as 0. The X values are 1, 0, 1 half, and then 1. So then we want to count how many ones, how many zeros are in this what? This 16 possible samples. Okay, that is 1 out of 416. So you enter this in the Stash Crunch, sorry, in your homework the same way. How many halves do we have there? We have 1, 2, 3, 4, 5, and then what? 6. So this is what? 6 out of 416. And then how many ones are there? Of course, the rest, that will be 9 out of 416. Now notice that, okay, this is a probability distribution. It's a probability distribution because the random variable X has what? Numeric values, and the probabilities corresponding probabilities are less than, greater than 0 and less than what? 1. And then when you add them together, you get what? 16 over 16, which is what? Which is 1. So this is our probability distribution, and we want to what? Find the mean and then check and see if this will, it's a bias or unbiased or estimator. Okay, so now let's go to the next slide. Okay, we have our probability distribution, which is X, okay, times the probability P. Here we have for 0, 1 half, or 0.5, and then 1. This is 1 out of 16, 6 out of 16, and 9 out of 416. So the mean of the sample distribution of sample proportion. So here is the mean of sample proportion. Okay, is equal to the expected value. Okay, the expected value. So it's going to be what? The 0 times its probability, 1 over 16, plus the 0.5 times its probability, that is 6 out of 416. Then you have what? 1 times 9 out of 416. Now, when you evaluate this, you're going to have 0 plus, okay, you have 0 plus 3 over 16, and you have what? 9 over 16. Now, when you add this, you get what? 12 over 16, which is equal to 3 over 4. Okay. So that is this is the what do you call this? The mean of the sample proportion. Okay. So the question is, what is the C? Is the mean of sample distribution from part A equal to the population proportion of mean? Okay. So what is a population? So you can say that this is your sample proportion, which is what? The mean of what? Mean of the sample proportion, p hat. Okay. So what is the mean of the population proportion? Okay, we use the capital P for that. Okay, we use a P for that. All right. Now, according to this, the question, we have what? We have Billy, we have Carlos, we have Danny, and then what? We have Elena. Now, how many males are here? Okay, so your population proportion is number of males, which is what? 3 out of the total, which is 4. Okay, now you see that in this case, the question is it equal? Yes, it is what? It is equal, yes, because, okay, the p hat, or you say that the mean of the sample proportion equals the mean of what? The population proportion. Okay, so what does it mean? Now, since they are equal, we say that the p hat is what? Unbiased. estimator of what? The population proportion. Okay, so see that 334, which is 0.75, is equal to that. We consider the number of males because X is the proportion of what males in the sample. When you consider only 2. Okay. Then the next question, 6.3, okay, talks about the median. Okay, the 3 randomly selected households are surveyed. The numbers of people in the households are 4, 5, and 9. Now, notice that these values could change. So assume that the samples of size 2 are randomly selected with replacement from the population that is given 4, 5, and 9. Listed below are the 9 different samples. Here they've listed the samples for us. Okay, it said find the median, okay, of each of the 9 samples, then summarize the sample distribution of the medians in the format of a table representing the probability distribution of the distinct median values, Okay, so here you want to know what is we already have the samples are given. Okay, so let's define our X. What is X here? This is the sample what? Sample median. Okay, sample median. Okay, now I think we use the tilde. Okay, sample median. In this case, just use that. So we're going to find the samples and the median. Median is what? You have these 2 samples. Okay, let's get the median. So you have what? You have 4, 4, 4,4, 4,5, 4,9, and we have 5,4, 5,5, and then we have 5,9, and we get 9,4, 9,5, and 9,9. Okay, now these are my X's. All right, these are the possible samples. There are 9 of them. Okay, what's the median? The median is what? These are 2 of them. So you take the average of 4 as 8. This is 4. This is going to be what? 4.5. The median, that is 9 divided by 2. And that is going to be 13 divided by 2, which is what? 6.5. Okay, so you have 6.5. And then here is also 9, which is what? 4.5. This will be 5. And here you have, you're going to have 14. This is what? The X, okay, is what? Is 7. And over there, X is what? 6.5. And then you get 7 here. And then you also have what? You have 9. So the probability distribution, the probability distribution, you have what? You have X, okay, and then you have the probabilities, okay, probabilities. Now, what are the possible values of X? Okay, if you start from the least one, we have 4. We have 4. We get 4.5. Okay, we got 5. We got 6.5. And then we have 7. And we have what? We have 9. Now, what are the probabilities? How many 4s do we have? There are 9 of them. We have only 1 4. So that is the probabilities of 1 over what? That's frequency, relative frequency. Okay, 1 over what? 1 over 9. Now 4.5, how many are there? We got 1, 2. So that is what? 2 out of what? Out of 9. Now 5, how many? That is 1 out of 9. 6.5, we have 1, 2. That's also 2 out of 9. 7, we have 2 out of 9. and then 9, we have 1 out of 9. Now, if you add all this, you are going to get what? The probabilities, you get what? You get 1. Okay, so the question is that we want to find the mean of the sample median. Okay, mean of the sample median, which is the expected value. Okay, let's go to the next slide. Okay, so I'm going to repeat this, what we got there. So there you have, you got X, and you have the probabilities. Okay, here 4, 4.5, 5, 6.5, okay, 7 and 9. And this is 1 out of what? 9, 2 out of 9. This is 1 out of 9. This is 2 out of 9. This is 2 out of 9. And this is 1 out of 9. Like I say, if you add everything, you get 1.0. Okay, that's a probability distribution. So the mean of the sample median, okay, is the expected value. So you have what? You get 4 times, okay, 4 times what the probability, that is 1 over 9, plus 4.5 times the probability, which is 2 over 9, plus 5 times the probability, which is 1 over 9, plus 6.5 times this probability, which is 2 over 9, then plus 7 times its probability, which is also 2 over 9, and then plus what? 9 times its probability, which is 1 over what? 1 over 9. Now, if you calculate all this together, okay, which will give you 4 over 9 plus 9 over 9 plus 5 over 9 plus 13 over 9 plus 14 over 9 plus 9 over 9. Okay, now everything will give you 54 over 9, which is equal to what? Is equal to 6. Okay, so to answer part C, we need to calculate what the population median. Okay, the population median. So first, find the population median. The population median. Okay, our sample is what? 4, 5, and then 9. What's the median of this? Okay, the population median, if we use whatever it is, what's the population median? What's it? You have for 4, 5, and now what's the median? If you arrange it, okay, and then you pick the middle. So the median is, so population median is what? Is 5, which is what? This value, which is the middle. Okay, so you could see that the mean of what? The sample median is not equal to what? The population what? Median. Because you got 6 is not equal to what? It's equal to 5. The 6 is from here, and this is 5. And so what's your conclusion is that you conclude that the sample median, okay, the sample the sample median, okay, is biased estimator of what? The population median. Okay, so proportion is what? Is unbiased. The median is what? Biased, because the mean of the sample median is not what? Equal to what? The population median. So it is what? It is biased. And then the last example is we want to look at the sample means. Okay, the sample means of the, okay, the sample means. Okay. So here again, we have 2. Okay. We are given 2 what? The population is, we get 37, 27, 23, and then 11. And then we are considering what? 2. All right. So we want to identify all the 16 what? 16 samples. Okay. And then we will find the probability distribution, calculate the what? The mean of the sample mean, and so on and so forth. Okay. So here we will define our X as what is the sample. We know the X bar. X bar is the sample mean, right? Let's define this as just what? That's the sample mean. Okay. Okay, let's do it. This is we're looking at for this the sample mean. Okay, which is, we know that notation is what? It is X bar. All right, let's use S for the sample mean. So that be consistent. Now, what are the possible samples? Okay, what are our possible samples? Okay, and what will be our the sample mean for each of them? Okay, the possible samples will be, since that with replacement we can have 37 and then 37. We can have 37 and 27. We can have 37 and what? 23. And then we can have what? 37 and 11. Or 27 and 37, 27 and 27. We got 27 and 23. And then what? 27 and 11. Now, if you continue like this, let's put the X here. I'm going to put X bar here. Okay, we can have 23 and 37, 23 and 27, 23 and then 23, and then have for 23 and 11. And we can have 11 and 37, 11 and 27, 11 and what? 23, and then 11, 11. So what's the sample mean? What's the mean of this? If you find a mean, just like we calculated a median, you add the 2 divided by what? Divided by 2. So this is going to be 37. Okay, for the first one, that is for this guy. And this will be what? It's going to be 32. Okay, this will be 30. Okay, and then this will be 24. That's for that. Okay, and then if you have that should be 32. Okay, this will be 27. This will be 30. No, sorry, 25. Sorry, this is 25, and this will be 19. And then when you go here, 23 and 37 is 30. Okay, and we have 25. This is your X bar. Okay, and then you have 23, and then 23 and 11 will be what? 17. 11 and 37 will be 24, and this will be 19, and we have 17 and then 11. Okay, so the X values takes on these values, 37, 32, all these values here. That's your sample. Okay, so then our population probability distribution. Okay, probability distribution will be when we put all this together and then what? And write them down. All right, so I'm going to write this. Let me put it here. So your X bar, and then have your probabilities. That's a relative probability. So I'm going to just do 37, okay, 37, 32, 30, 27. In the descending order, it doesn't matter. You can start from, and they have 25, we got 24, we got 23, we got 19, we got 17, and then what? And then 11. Now the probabilities are the following: 1/16. Let's count them. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. He said what? There are 16 possible what? Samples. Okay, we got that. And then the next is 2 out of what? 2 out of 4, 16, because there are 2 32s, this and that. And then we do it for 30. It's also 2 out of 16. 27 is also 7 is 1 out of 4, 16. 25 is 2 out of 4, 16. 24 is also 2 out of 4, 16. 23 is 1 out of 4, 16. 19 is 2 out of 16. And then 17 is also 2 out of 16. And then 11 is what? 1 out of 4, 16. Now let's add them together. The denominators: 1, that is 3, 5, 6, 8, 10, 11. Okay, 11 plus 4, 15, and then 16. So if you add everything here, you get what? You get 1. Now to find the mean of the sample mean is what? The expected value, which will be 37 times 1/16, 32 times, like that, all the way, and then you add them together. Okay, so let's go to part B. Say find the mean of the what? Of the sampling distribution of the sample mean. Okay, this is the expected value. So from this table, like I said, we're going to multiply there to be 37 times its probability, 32 times its probability, just like we have been doing. All right, so the mean, okay, mean of the sample mean, okay, mean of the sample mean X bar, okay, is going to be, when you calculate all that, you multiply each of them by the what? By their probabilities, okay? Or the mean of this is the same as the mean of a sample a sampling distribution, okay, which will be 37 times 1/16 plus 32 times 2/16 plus 30 times 2/16 plus 27 times 1/16 plus 25 times 2/16 plus 24, okay, 24 times 2/16 plus 23 times 1/16 plus 19 times 2/16, then plus 17 times what? 2/16. And then finally you have what? 11 times what? 1/16. Okay, so when you calculate this, you're going to have what? 37/16 plus 64/16 plus what? 60/16 plus 27/16 plus what? 50/16 plus 48/16 plus 23/16 plus 38/16 plus 34/16, then finally 11/16. Now calculating all this and simplifying it, okay, you have what? 24.5. Okay. Add everything and divide by what? 16. You get what? 24.5. So the question is that, is this biased or unbiased? Okay. First, we need to calculate the population mean. So the population mean of the, what's the population mean of the sampling distribution? Okay. The population mean, okay, our samples are what, 37, if you remember. I have 27, 23, and then 11. So we find the mean of that, which is what, 37 plus 27 plus 23 plus 11 over what? Over 4. Remember, this is the same as the x divided by what? Capital N. Okay. So when you do this, this is also what? 24.5. Okay. So is this biased? Yes. Okay. The mean, or it's called a sample mean, X bar is an one unbiased estimator. Estimator of the population what mean. In this case, if we use symbols, the population mean is what is mu. Okay, this guy is what we call, this is the mu. What we just calculated is the mu. That's your parameter, and this is your sample. Okay, that's your X bar. Okay, so far in these three examples, we notice that the proportions, the sample proportion is an unbiased estimator. The median, the sample median is what? It is biased. And then the sample mean is what? Unbiased estimator. Okay, so that gives us these three examples that we'll go over. You could see if we were to do this in class, just one example alone can take us the whole class time. And that's why I prefer to do this video. Hopefully this is helpful. Let me know, give me a feedback on this. Thank you. Appreciate it. Bye-bye.